Kia ora. Here are two more questions from the June 2022 paper. So nobody has asked for these, but I'm asking that you all watch these if you're in 13 NCA this year. I think they're both really nice examples of things that can go wrong in integration problems if you don't just go slowly through both of them. And the examiner's report noted that about both of these questions, especially the second one. So I'm going to do the first question in two different ways, and I'm going to show you the way that I think is better, which is really about when we substitute in the piece of information we've been given. And then in the second one, I'm just going to do it one way. So let's look at this first differential equation. So it's not too bad. We're given this little dE here. dy by dx is equal to xy over 1 plus x squared. And we're told that when x is 0, y is equal to 2. We have to solve it, and we have to get a simplified expression for y in terms of x. And you can see it's worth 7 marks, so there's going to be a bit of work to do. So let's just start off, and as usual, we will separate the variables first up, and then we'll integrate both sides. So separating the variables, we're going to get 1 over y dy is equal to x over 1 plus x squared dx. As I said in my last video, hopefully you've all watched, please don't go from here. Please make sure that you actually are integrating instead of just magically doing things. On the left-hand side, we're going to have the natural log of y, and on the right-hand side, we're going to have 1/2 times the natural log of 1 plus x squared plus c. Okay, things to notice in here. Notice that I have not done absolute value signs here because I know that 1 plus x squared is going to be positive. I spot straight away that I've got a function down here, and I've got a close relative of the derivative up the top, right? The derivative of 1 plus x squared is 2x, and I've got x. So that's all looking pretty good, nothing too bad. And so all we've got to do from here is just slowly put some things in. I'll just get rid of that silly line. Okay, now what? Well, at this point I substituted, right? And this is where I'm going to show you the second way to do it later. But I said at x equals 0, y is equal to 2. That gives me this. Natural log of 2 is equal to 1/2 times the natural log of 1 plus c. So the natural log of 2 is the value of the constant. Now, we need to get a simplified expression, so we'll pop all of that back in. We've got the natural log of y is equal to 1/2 ln of 1 plus x squared plus ln of 2. I'm going to work with my level 2 NCEA log rules now. So if you're watching this not from New Zealand, I guess I'm talking about the rules you learn in the AS year of A-level. So, and I'm going very slowly here, more slowly than you have to. So we've got the natural log of 2 root 1 plus x squared, and that's equal to the natural log of y. So doing e to the power of both sides, we get y is equal to 2 root 1 plus x squared, and that's it. Now, here's the other way that you can do it. I think it's not really that much more work, but it's just easier to go wrong if you're not confident with your log rules. So let's go back to the step here and see the other way. Right, well, we could try and get y as the subject at this point before substituting, and if we do that, it's kind of good practice for other questions where you might need to do this, right? So we do e to the power of both sides. We can split this up as e to the power of c times e to the power of 1/2 ln of 1 plus x squared. Now, students who are not that confident with their log rules, at this point we'll try and do something with the e and the ln. We can't do that. We need to make sure that we get that power of 1/2 up before we go anywhere. So we're going to have this. Now I'm going to rewrite that e to the c as big A, and here the e and the natural log do undo each other. So we've got 1 plus x squared to the power of 1/2, and we can substitute in 0, 2, and we get 2 is equal to a times 1 plus 0 to the 1/2. Right, so it's not bad, it works, and I'm sure that some of you probably would have done it this way if I'd put it in the school exam. That gives me that 2 is equal to a. I just think it's got more room to make mistakes. So there you go, that's the first question all done. Now the next one I think is a little bit harder. But it's still, I mean, it's basic fluency work with trig integrals and with understanding how to use substitution. So they've told you here to use a substitution and to show in the first step that we get to here, and then in the next step find the exact value of this. So even if you muck this up, you can get those last 4 marks. I think this is a lot like a NCEA level 3 question, so these last 4 marks for New Zealand students should be very, very easy ones. They also noted in the examiner's report that you could get there with doing integration by parts twice. Like, I haven't put that in here because, I don't know, it just doesn't look like an efficient method of working to me. So let's have a look. We're told to use this substitution and we need to get it to this point here. So I'm just going to, I've got a weird, silly thing on my screen that I'm just going to try and get rid of. Okay, that's better. So let's see what we've got to work with. We've got the integral between 3 and 0 of 27 over 9 plus x squared dx. And we're told to let x equal 3 tan theta. Straight away we'll differentiate. We get dx by d theta is equal to 3 sec squared theta. And separating the variables here gives me dx is equal to 3 sec squared theta d theta. So that's good. That means that I've got that one ready to switch out in terms of theta. Now the next thing to remember is that as soon as you see that you're working with sec squared theta, you should be thinking about your tan squared sec squared identity. So just in case you've forgotten where that comes from, let's just take our basic Pythagoras identity. When we divide everything through by cos squared, that tells me that tan squared theta plus 1 is equal to sec squared theta. And that's what's going to help me in that denominator. So now let's put our substitution in. If we've got 9 plus x squared, that's the same as 9 plus 9 tan squared theta, which is equal to 9 times 1 plus tan squared theta, which is equal to 9 sec squared theta. So that's this bit now sorted out, and this bit, and that bit's just a constant. So the last thing we've got to deal with are my 2 limits. I'll do that using the table that we've used all year. So we've got x here, x is 3 or x is 0. Now theta is equal to the angle whose tan is x on 3. I'll do that more slowly out here. So x is equal to 3 tan theta. That gives me x on 3 is equal to tan theta. So that's where this is coming from. Right, so tan inverse of 3 over 3 is equal to pi on 4. And tan inverse of 0 over 3 is equal to 0. So these are going to be my new limits. So now we're good to go with replacing everything. So my integral is, I'll write out the first one just so you can see it again. Right, first we replace the limits. We're going to have pi on 4 to 0, and we're going to have 27 over 9 sec squared theta squared, but my dx is going to be 3 sec squared theta d theta. So I actually I don't think I've done this integral before, and I think it's really elegant with how lots of stuff just falls out, because you can see now we've got pi on 4 to 0, and we've got 81 sec squared theta over 81 sec theta to the power of 4 d theta, and that gives me this. I'm going really slowly because it's a show that question, but we get down to that, and that of course is what we need to get to, which is the integral between pi on 4 and 0 of cos squared theta d theta. Right, now then part B says can we go and work out what that is. So this is just your standard, by far my favourite trig identity, double angle cosine. 2 cos of 2 theta is equal to 2 cos squared theta minus 1, cos of 2 theta plus 1 divided by 2 is equal to cos squared of theta. And if you're not feeling confident with that at this stage of the year, I think it's probably time to do some like Dr. Frost work on trig integrals or just some delta textbook work. So we've got that. That means that we've got that in a nice little box out the side. Plonking that into here, what do we get? We get pi on 4 to 0 of 1/2 cos of 2 theta plus 1/2 d theta. Right, integrating this, let's leave a gap for the coefficient. Well, sine differentiates to cosine, so it will be sine of 2 theta. I've got my half, but I need another half, so it's times a quarter, plus a half theta, evaluated at these limits. And we have 1/4 sine of 2 pi on 4, which is pi on 2, plus a half of pi on 4 minus 0 plus 0, because sine of 0 is 0. So that gives me 1/4 plus pi on 8, which is a very nice, elegant answer. The mark schedule, I don't know why, but I wrote it as 1/8 of pi plus 2. So there you go. Right, I hope you enjoyed those. Please keep on sending in the questions. Otherwise, I'm just going to keep finding ones that I think you should do. So really cool if you can send some in and maybe make them on something that's not integration, because I feel like we've done quite a lot of that today.